Hi to everyone, my name is Luigi Capogrosso and I am a third year PhD student at the University of Verona. My research interests cover the broad area of deep learning, and the main topics I am currently working on can be grouped into the classes of representation learning and efficient deep learning. Indeed, I'm glad to present today our work named A Machine Learning Oriented Overview on Tiny Machine Learning Theory, Methods, and Applications. Specifically, I will first give a brief introduction about the TinyML research field. Then I present the learning panorama under the TinyML lens and discuss the different workflows in order to implement a TinyML based application. Finally, I will briefly discuss some open challenges and future works. So, as we know, the TinyML research field had a great impact on the field of artificial intelligence, promoting the joint design of resource-constrained hardware devices and learning-based architectures. But we also know that the challenges for TinyML interns are very hard. For example, in modern neural networks, among the best currently available technologies, the number of the required parameters has rocked to the order of billions. And given its multidisciplinary nature, the field of TinyML has been approached from many different angles. This comprehensive survey that we published this year on IEEE Access Journal, so it is an open access paper, wishes to provide an up-to-date machine learning oriented overview on TinyML, discussing theory, methods, and applications. In particular, we provide an update overview of the evolving state-of-the-art field of TinyML. Since, as we can see from this figure, the number of research articles published on TinyML is increasing exponentially, and also the number of surveys and papers on the subject is following suit. Specifically, we think that in order to unlock the full potential of TinyML, exploring and understanding the complexities involved in designing and optimizing machine learning models for specifically resource-constrained devices is essential. As a result, this figure represents our proposed taxonomy of the learning panorama under the TinyML lens. Since there is not much time here to explain the entire work, I will only report the different outcomes below. But I invite you to read the paper, in which you will find much more specific and detailed information on each of the approaches shown here. So, the model optimization is the area that has received the most extensive exploration. We can find several cutting-edge works that explore techniques such as pruning, quantization, and knowledge distillation. On the contrary, the scarcity of research focusing on hyperparameter optimization can be due several factors, such as its complexity, the fact that it is a task that requires a lot of research requirements, and in a certain sense also for the lack of awareness about the importance of HPO and its potential to enhance the performance of machine learning models. Regarding the model design area, we have that the most of the work in this area are focused on neural architecture search. Another significant portion is related to attention mechanism and depth convolutions. Despite the number of advancement made in machine learning by applying rational activation functions. Now, no such methods has been found in any works related to TinyML. And we believe that opening a research in this direction could potentially lead to further enhancements in the quality of the produced models. Finally, regarding the learning algorithms, a significant body of research focused on unsupervised and continual learning. A lot of efforts have been made in also supervised learning, meta-learning, and deep reinforcement learning. Instead, self-supervised and weakly supervised learning fields still require more effort. Then we asked ourselves, at the state of the art, how are the different techniques in order to realize a TinyML based application? Or better, which are the different workflows in order to realize this type of application? As we can see from the figure on the right, there are three different possible workflows: the machine learning oriented one, the hardware oriented one, and the co-design. Specifically, in the machine learning oriented one, the majority of the effort is in the design, the adaptation, the training, and the evaluation of machine learning models. And the choice of the hardware platform is fixed or limited. On the other hand, in the hardware-oriented workflow, the developers mainly focus on designing enhanced hardware platform. So the focus of these engineers is to produce the best hardware in order to execute as best as possible some fixed deep neural network models. Finally, the co-design approach is the one that integrates both sides of the previous development. In particular, I have two groups, one composed by machine learning specialists and the second one composed by hardware specialists that cooperate together in order to unlock the full potential of TinyML. Within our article we discuss many more things, but since I don't have much time yet, I invite you to read the paper again, in which you will find much more specific and detailed information, like for examples, which are the hardware devices that are most widely used to date. And now I'm going to conclude this presentation by talking about some challenges that are still open today. The first one is the lack of accepted models. We have that many deep learning models are widely accepted for conventional infrastructure. For example, MobileNet is the baseline for benchmarking deep neural networks in mobile age devices. However, no such popular models can be adopted also for the TinyML on the MCU ecosystem. The second one is the lack of public dataset. Because despite some datasets specifically designed for TinyML are available, a question emerged. What is the ImageNet of TinyML? And finally, we have the memory constraints, because the greedy demand for computation and high accuracy has continued to push the innovation in the machine learning and deep learning fields. However, the extremely small size of memory makes the task of deep learning on edge devices very challenging today, with also the advent of generative AI. Okay, this concludes my presentation. If you have any question, feel free to ask, and yes, thanks again for giving me the opportunity to present there. If you need more information about the paper, you can scan the QR code attached here or simply visit my website.